Name of this presentation is History and Future of React Native App Development for Demae-can. Uematsu and Kurosawa, very nice to meet you. Since we are going to talk about the React Native, let me talk about ourselves first. I am Uematsu. I joined UIT, Front-End Development Center in 2019 as a mid-career front-end engineer. I was mainly in charge of the front end of the financial services such as Line Securities and Line Insurance. I was transferred to Demae-can in February this year, and since then I have been in charge of modifying the application used by drivers, and now I am in charge of developing the Demae-can application used by everyone. I'm currently working in Kyoto office and live in Arashiyama, a 5-minute walk from Togetsukyo Bridge. Recently, I've been in Apex Legends and also Valorant and am playing them at night. I've been working in the front-end field for more than 10 years, mainly in React Vue SPA development. And I am Shinji Kurosawa. I have been delivering iOS application using Swift Object-C as an iOS engineer for about 4 years. I joined Line in 2020 and was developing Line official accounts using Swift. Since April this year, I've been developing the Demae-can app. This is the first time for me to develop using React and also React Native, so I am learning more and more every day. Since I moved to Kyoto in April, I would like to enjoy visiting temples and sightseeing in Kyoto when I get settled. In this session, I would like to talk about 3 main topics. You may be wondering why the developers of Demae-can are speaking at linedevday in the first place. So I will talk about the relationship between Demae-can and Line and also overall picture of the Demae-can system. Next, I will talk about the changes in the organization of Demae-can application team, what the current development team is working on, and the development culture. Lastly, I would like to talk about the challenges and a solution in developing the mobile app for the Demae-can. So, first one about the Demae-can and Line. Let me talk about the Demae-can first. As many of you in Japan may know, Demae-can is one of the largest food delivery services in Japan. You can use it from your PC, smartphone, browser, or iOS or Android app. In terms of numbers, the Demae-can currently has more than 84,000 member stores and more than 7.3 million active users. The number of users has doubled in the past year, and we feel that the service is entering a period of significant growth. The only part of the Demae-can that users can see when they place an order is the Demae-can application or the web browser screen, but behind the screen, various applications and systems are running. There are 2 main types of delivery systems. The first is that the merchant already has a delivery system in place. The main role on the Demae-can is to coordinate orders to the store. When the user places an order, the information is relayed to the store via Demae-can, and the store's delivery staff delivers the product to the user. The second is the sharing delivery mechanism. In sharing delivery, the order information is linked to the store as in the previous section. In addition, the information is linked to the delivery staff of Demae-can, and the delivery staff of the Demae-can picks up the product at the store and delivers it to the user. A variety of systems exist to realize these mechanisms. For example, a delivery application that delivers order information to the delivery staff after the user places an order with the Demae-can. An app for merchant to check order information. an app for merchants to check order information, and an administration screen to manage product information. We also provide analysis tools for stores to visualize their sales, number of deliveries, popular products, and many of these systems are working on a single order. Each of these systems currently involves a large number of line engineers. I think there are lots of people who don't know why line engineers are developing the delivery service. So let me give you a brief explanation of a relationship between line and Demae-can. In fact, we have been involved in a business partnership with line since 2016. In 2017, we released a food delivery service called linedevday. In 2019, we released Line Pokeo, a service that allows customers to place takeout orders. Both linedevday and Line Pokeo were developed and operated by Line, but behind the scene, the systems and know-how of the Demae-can were utilized. With the Capital and Business Alliance formed last March, Line Engineer became involved in the integration of Line service and Demae-can in order to accelerate the growth of these services as a single entity. The first app member joined us in May of last year, 2020. Initially, we focused on the apps used by merchants and drivers. In April of this year, we started working on the development of the Demae-can app and have been involved in the development for about half a year or so. With this history, line engineers are now involved in the development of the Demae-can. From here, I would like to introduce what kind of changes have been made in the development system and culture of Demae-can application team over the past 6 months. First of all, let me talk about the development team of the Demae-can app. The application team is currently composed of members based in Tokyo and Kyoto. We also have a development partner from Okayama. Of course, we have a system for remote development, so we use Slack and Zoom to communicate closely and develop every day. As for the entire Demae-can, CS staff are based in Kagoshima, QS staff are based in Tokyo and Fukuoka, and development members including server side are based in Osaka, Kyoto, and also Tokyo. Before we joined the team, we were developing the application with 2 external development partners. Furthermore, the 2 of us were developing the browser version of the PC smartphone application and iOS Android application. Of course, it was difficult for the 2 engineers to plan and revise the browser application while developing it with maintainability in mind, so they had to make a lot of compromises. This lack of resources was also one of the reasons for selecting React Native. And now, this is a development team for the current Demae-can application. Since April, we have gradually increased the number of members, and at the moment we have 4 iOS engineers, 2 Android engineers, and 1 front-end from Line participating in the development of the Demae-can app. We are also continuing to work with external development partners. In the past, 2 people were developing both the web and the application, but now we have nearly 10 engineers working on the application alone. One of the characteristics is that there are many native engineers participating in the project instead of front-end engineers. Since this is application development, there are inevitably situations that require expertise in both operating system or issues that require investigation, but I think the strongest part of the current team is that we can resolve most OS-independent settings or issues that require modification relatively easily when they are shared with the team. Of course, most of us have not developed mainly in JS before, so there are learning costs. Later on, Kurosawa will talk about the learning cost and also how he promoted learning when he started working with React Native from a native engineering perspective. Next, I would like to talk about what the application team has been working on as the system has changed. As I mentioned earlier, the app team was originally developed by 2 people. So after I joined the team, I had to start building the foundation for team development. I think the most common problem that arises in small group development is that the various phases of development become more and more dependent on individual experience. In the same way, the specifications, business logic, and build environment of the Demae-can application were really dependent on the individual experience. Until now, there were only 2 developers. It had to be done due to the lack of resources. However, in order to proceed with development as a team in the future and to continue to provide a stable product as a service, it was necessary to create a certain level of standardization. It was necessary to create some standardization rules and a language. So in order to develop as a team, we had to lay the groundwork for basic rules, consistent development, and sustainable development. We created basic rules for app development operation. As for the version of app, React Native has 2 main types of release, binary releases and OTA releases. OTA stands for over the air, and it is a feature that allows you to distribute only the JS bundle separately. By using OTA, it is possible to update applications without having to apply to the store. As for versions, the rules have been rewritten to take into account planned binary releases, OTA releases, and hotfixes in case of problems. It's simple, but I've made it so that major versions are binary updates, minor versions are OTA updates, and hotfixes are incremented as patch versions. You can see the current version at the bottom of my page of the application, so you can imagine what the current version is like. Next is the Git rules. The app team uses GitLab flow as a basis for managing the code. One thing to keep in mind when developing React Native is that if you distribute a native module that needs to be added or updated OTA, only the JS bundle will be updated, which may cause problems. Therefore, we use a version rule mentioned earlier to clarify binary releases and the release branch to manage the source code. After the transition to team development, we also introduced Scrum. There are many things that we need to catch up on during the transition to team development, so we are currently running a 1-week sprint. Task management is done in Jira, but there were many things that were not managed as an application team, so to make it easier to manage, we have been using boards, labels, epics, and creating rules for drafting. Next, what we did to maintain the consistency of the code. First of all, the type system. I know that everyone uses Flow or TypeScript, but when we joined Demae-can, the entire code base was TypeScript. However, since we migrated from JavaScript, any is used in various places, and we were working to eliminate it. At least for newly implemented screens, we are trying to implement them with the assumption of no implicit any. And linter and prettier is almost a standard in web front-end development, but we were not using it in our existing code base. When I joined the project, the first pull request I made was to format all the code in the app and fix lint errors. The goal was to reduce the review loaded by giving the team a rule to avoid indenting or pointing out small details. SonarQube is a static analysis tool for code. We have introduced it as a measure to ensure the quality of the code in each modification or feature implementation. We are currently doing a large-scale refactoring, and it evaluates the complexity of the files, so I refer to it when deciding the priorities. As for test, as you can imagine from the fact that it was developed by 2 people, there was no test implementation. Currently, we are using unit tests to test the logic, and tests are being added steadily. Also, since business logic and UI logic were intertwined, we introduced snapshot tests to check if there are any extra UI differences after refactoring, or if it affected other components. We have considered E2E test, but decided that it is not the right time, so only the ticket is lying in the backlog. We are considering implementing it only for the important part of the main flow, such as the payment part, on a priority basis. We have been using them as a team to ensure consistent development and maintenance. The last part is the maintenance for continuous development. The first is a build environment. Kurosawa will talk about the details later, but we used to do build in the local environment of our personal computers and upload the result to the store. There were various differences and dependencies such as Node version, Xcode version, that were not visible to the eye. Currently, we are using a service called Bitrise, which manages the workflow of OTA build creation and binary build. With a single click on the browser, we can automatically create a binary for QA and release and then upload it to the store, all without depending on the individual environment. Especially in the build phase, I think the knowledge of each native engineer is fully utilized. We also use the GitHub Actions to perform automatic checks such as test, lint, and prettier, as well as automatic static analysis of pull request ref using the SonarQube to reduce the burden of code review and allow more time for development. In addition to the above, we have also added the following features. So there are the improvements that we have made so far to be the foundation for team development. Finally, I would like to talk about what the Demae-can team is working on right now. There are 3 main things we are working on: maintainability, stability, user experience. We are working to improve those 3 things. In terms of improving maintainability, that we are working to reduce the complexity of the existing code base, which is a complex interplay of business logic and UI logic. Kurosawa will talk about refactoring in detail later. We also use a lot of third-party packages, and we are trying to keep up with the updates of each package. But we also need to verify the compatibility with React Native, so we are working on bringing it up to date little by little. We have also introduced Renovate to keep up with package update.
Also, as I mentioned earlier about the separation of business logic and UI logic, UI is becoming more common between web and application. We are working on migrating the business logic on the front of the web application to the BFF side. The application engineers who are writing TypeScript in React Native are also participating in BFF development. Next, regarding stability improvement, Demae-can is now making major improvements to applications as well as to our entire system. API changes, etc. had to be handled by the application and web. I believe that the migration of business logic to BFF will be effective in lowering development costs. As for crashes, we are using entry and app center crashes to collect logs. Currently, crash rate is kept around 0.1%, and we would like to keep it in the future. As for improving the user experience, we are making improvements every day, and one of the major topics is building the design system for Demae-can. We will gradually adapt the design system to improve usability as an application. One of the advantages of implementing a design system is that as the services grows rapidly, the planners, designers, and engineers can share a common understanding, reduce necessary communication costs, and manage stable design quality. As a result, we can expect to see faster project progress, higher quality, and improved brand recognition, which is beneficial from an engineering as well as from a business perspective. Also, since the UI has a lot in common with the web, we are watching for the possibility of React Native for web and React GUI. Since Demae-can Web also uses React, we are also planning to verify the commonality as we build the design system, excluding the areas that are strongly related to native. That is all for we have been doing as the Demae-can App development lead since I joined the development of the Demae-can App in April this year. Now that the foundation for Demae-can App development is in place, we have created an environment where we can accelerate the development in stability. In order to further accelerate the growth of the services, we plan to develop and improve the services from various angles. That is all from me. Thank you very much. I'd like to hand over to Mr. Kurosawa from here. I'd like to talk about the difficulties we face in developing Demae-can App, the solution, and the current situation. Before I talk about the difficulties and solutions, let me review the current membership of Demae-can App. As I mentioned, we have 4 iOS developers, 2 for Android, 1 front-end developer added, and partners. Since we are developing React Native applications with this member composition, some may wonder while listening to our talk. Why do they use React Native? Why didn't they rewrite it in Android iOS Native? I'm sure some of you may have these questions, so I'd like to start by explaining why we use React Native in Demae-can App. First, let's review the features of React Native. React Native is a tool that enables cross-platform development for Android and iOS by leveraging React knowledge. It is written in JavaScript code and has features that are unique from the perspective of native Android and iOS engineers, such as OTA update. I won't go into the specifics of React Native here, but I did review the features. Based on the features of React Native, I'll try to explain why we're using React Native in our project and why we keep writing in React Native instead of moving to Android iOS Native. Replacing it would be very difficult and costly since the existing code was React Native and the Demae-can App consists of quite complex logic and domains. One reason is it's better to keep maintaining React Native than revising as a business phase. The second reason is since Android and iOS can be managed with a single source code, which allows for speedy development. Multiple features are currently being developed by multiple teams at the same time for Demae-can App. It is tough to develop at the current speed without using cross-platform, so it was good that we chose React Native. In the future, we have the option of rewriting with Android iOS native apps, but in order to continue speedy development, we have decided that using React Native is the best way for now. Based on the above background, I would like to talk about the difficulties and solutions in developing the Demae-can App and the current situation. The first task was to learn React Native, which is a prerequisite knowledge for developing React Native applications. In this section, I would like to talk about the cost of learning React Native, which was necessary to develop the Demae-can App. I just gave you an overview of React Native, and I'll explain what Android iOS developers actually need to know in order to develop React Native app. First of all, in order to develop React Native apps, you need to have some knowledge about React and React Native. It requires a lot of knowledge about declarative UI, function components, hooks and React Native components, and using React Native in the native layer. Next is the language. React and React Native use JavaScript. Demae-can App uses TypeScript, so we also need to know TypeScript. TypeScript has some similarities in notation with Swift and Kotlin, but there are many differences in philosophy that required learning. Finally, we need to understand the environment and libraries for React Native development. There is a lot of knowledge required, such as NodeJS, build system, IDE, network, understanding of architecture, and testing framework. In order to learn all of this knowledge, there are issues such as the cost of learning. In order to develop an app using React Native, you will need to have the knowledge I mentioned earlier. Especially in our team, there are many Android and iOS developers, and many members had no experience in React or React Native development. In addition, Android and iOS developers frequently join the environment, so newcomers will have to pay a learning cost to learn React and React Native. Our organization has allowed for some of these learning costs, but we have taken some initiative to reduce it, which I will explain some. There are mainly three approaches taken to learn React Native. First, we try to learn from engineers who know React well. In our team, there are several engineers who know React very well, including Mr. Uematsu, who made a presentation earlier. For this reason, I'm sure to consult with an engineer who knows React first. React Native uses a lot of React technology, so having engineers who are strong in React is very important. Also, for a larger project, we created a thread on Slack to work on. And we created a system that allows us to solve problems earlier at points where beginners often stumble by enabling us to know the troubles as early as possible. We also have weekly mob programming and study sessions with the team. There, we work on minor bug fixes and refactoring as a team and share newly introduced technologies. Lastly, we are documenting the knowledge we have learned. I try to document tips about React and suggestions I receive in pull requests so that new members can learn effectively. As a result of these efforts, Android and iOS engineers are now able to use React Native, and new joiners are able to learn more efficiently. In addition, since there are apps and web services in Demae-can, we are currently communicating with the front-end team to promote team development. I'll talk more about this later, but since the front-end team is using Next.js, we are working to make more efficient development in apps and the web as well. One of the best things about learning React Native is the ease of having code-based consulting with the front-end team. Then I will talk about refactoring as a difficult part. In Demae-can App, a lot of rendering logic and business logic are concentrated in a single component, and it took a long time to understand the code. Another challenge was to rewrite components written in class component with function component in order to use newer technologies. In addition to these code-based issues, there are many domains in Demae-can services. Therefore, it was necessary to understand the domains in order to refactor the business logic. To make the refactoring as fast and safe as possible, we take full advantage of the React Native ecosystem. The diagram shows a series of steps from build to pull request when developing Demae-can App. First, build for Android iOS. Build of native modules for Android iOS is required only when there is an update to the native modules. So basically, you do not need build native modules that take time. set up a local server to use the React Native JavaScript bundle. The next step is to make changes in the editor. React Native comes with hot reloading function, so you can check the changes immediately by saving them in the editor. In addition, we often implement Storybook because Storybook is a simple way to check the UI. Once the changes are complete, it is time to implement the test. You can use story shots against the storybook that you just wrote, as well as business logic, to do a snapshot test on components. Once you have implemented test, you can submit a pull request. As a check for the pull request, we'll run a test for each of the Android iOS React Native modules depending on where the changes were made. We also use SonarQube to measure the coverage of the test code and to visualize and technical debt. After the pull request has been merged, release is performed. When a pull request is merged into release branch, the staging up release is automatically executed on CI. As a result of these efforts, a large amount of logic in a single class component is described. So the code has been refactored in this form. The UI logic was described only inside the component, and the business logic was separated. By dividing the UI components and writing tests appropriately, the role of component is clarified. We also migrated the class components to function component and used hook for business logic. By writing unit tests in hook, we also ensure the safety of the business logic code. So far, the business logic of the application has been separated from the UI. However, there are still some issues with the current Demae-can app and web. The issue is that we often write the same business logic for both Demae-can app and the web service. If I'm going to write the same business logic for the app and the web, I want to keep it in one place. Since the web app uses Next.js, I'd like to manage it in one code if possible, rather than writing TypeScript hooks in the app and web and managing two codes. We are currently working on the commonization of business logic through BFF Backend For Frontend. This BFF server is not strictly designed only for common business logic, but since the focus of this presentation is on refactoring, you can think of it as for refactoring. By creating an intermediate layer between the client and the back end and making requests through GraphQL from app and web, it is possible to handle only the necessary information on the client side. BFF server is written in TypeScript and is front-end team-driven. As a recent effort, the application development team has also started to develop a BFF server. Recently, implementation is done in the form of migrating business logic carved out of the app team to BFF. I've actually started developing the BFF server, but since I usually write React Native in TypeScript and the BFF server is written in TypeScript, I was able to smoothly start development, and I'm glad that we developed React Native. In this way, we are currently promoting team development in the application and web team. Finally, we prepared for continuous release of many features by multiple teams. When the Demae-can app development started, there was no CI/CD because the environment was not designed for large-scale development. In order to move to large-scale development, we faced with the challenge of automating release process. We also needed to manage a large number of features and release them quickly while keeping proper product quality. Finally, in order to continue releasing quickly and continuously, we needed to set rules within the development team. These efforts have been made in preparation for the continuous release of many features. We spent 4 months to create CI/CD environment with one dedicated engineer. We have semi-automated almost all release tasks such as App Store, Google Play, Qt OTA updates, and staging releases, and have a well-developed CI/CD environment including pull request check. Next is release management. In order to ensure continuous and speedy release, we asked support from the Line QA team to do quality assurance for us. Release schedule and many functions are documented for management. Finally, about OTA updates. We decided branching strategies, versioning control, and OTA updates process and everything when hotfix is needed. The ability to use OTA updates as hotfix shortened the lead time for emergency hotfix, which in turn makes it easier to quickly develop multiple features. Summary. The Demae-can app has been transitioning from small group development to large-scale development. By making many improvements, we now have a system in place and a React Native development environment has been enhanced. We are still working on various initiatives to ensure speedy and continuous development. That's all about the past and future of the Demae-can application. Thank you very much for your time.